Welcome. Welcome to the first lecture of the series on computer networking from scratch. Now in this series we shall be talking about computer networking, digitalization, computer architecture, digital logic and much more. So this is an integrated approach towards learning the subject, and that is something which is asked in your GATE exam. Also for engineering students who really wish to understand that topic in depth, so that in future they can go ahead and pursue it as a career. It would be remarkably interesting to know that this subject is good for anyone who is seeking knowledge. Now before we proceed, in case if you have not done, kindly subscribe the channel and press the bell icon for instant notification of new training sessions. Now this would be an absolute step-by-step approach with a precise target to develop a solid foundation. I shall be preparing a separate series for rapid revision, so do not skip anything at this point of time. Keep an absolute patience and listen to every word carefully. It is particularly important that you make the notes parallelly while watching the video. As we shall proceed in the series, we shall be covering more and more detailed concepts. So let's start. We shall talk about concepts of computing systems, also evolution or birth of computers. The purpose is to give you a solid understanding of how our computing systems work. But at the same time, I wish that you develop an appreciation for the evolution of modern computing systems. So starting with computing system. If you have noticed, we use the term computing system, not just computer. A computing system is a very dynamic entity. It is something which is used to solve problems and interact with its environment. A computing system is composed of hardware, software, and the data that it manages. Computer hardware, it is the collection of physical elements that make up the machine, and its components like CPU, hard disk, monitor, keyboard. And when we talk about computer software, it's the collection of programs that provide the instructions that the computer will carry out. And at the very core of the system is the information which it handles. So comparing in medical terms, you can say brain is the hardware, while mind is the software and thoughts are the data. Now computing system is like an onion which is made up of multiple layers, but every layer has a specific role in the overall functionality of the system. As we see that it's the information at its core. Then comes the hardware, after that there is programming, operating system, applications and communications. Now this core layer information is managed using binary digits 1 and 0. This is the reason why we must understand the binary number system and its relationship to other number systems like decimal, hexadecimal. We shall be talking about the finest method to calculate binary, decimal and hexadecimal in our subsequent lectures. The hardware layer. It consists of a physical hardware of a computer system. So this is the area which comprises of devices working on the principles of gates and circuits. And these gates and circuits, they control the flow of electricity. And that's how hardware components like CPU and memory actually functions. Moving on to the programming layer, that deals with software. Now this software are the instructions used to accomplish computation, and they manage data. These programs can be of many forms, many different levels, and can use many languages, but the final purpose, it remains the same: to solve problems. Operating system. It is responsible for management of computer resources. Operating systems are like Windows, Mac OS, Linux, and they all have the common purpose. And that purpose is to manage the way hardware devices, programs, and data they talk with each other. That's the reason it is so important to know your operating system well. The next layer is application layer, and it focuses on using the computer to solve specific practical problems. Now, whether you are sending a mail, or you are listening to a song, or even watching a movie, collectively they all are applications. A very wide range of applications are available in the form of 3D simulations, artificial intelligence, and very advanced lifelike gaming experiences. All are applications. And then comes the communication. No computer in today's world works in isolation. That is where the concept of networking comes in. Computer networking is when two or more devices communicate or talk with each other to share information and resources. This decreases the cost and increases the speed. That's the reason it is very wise to adapt to technology professionally, which is always progressing. Also, there is a concept of abstraction. In fact, it's a mental model, a method to think about something that hides complex details. The purpose of hiding complex details is to reduce complication. For smooth operations, we should focus on the outcome and not the complex details about system operation. Now, it has been proven that the human mind can actively manage about 7 pieces of information in short-term memory at any given point of time. It may increase or decrease by 2 or 3 depending upon the person, but as such it's about 7. Now, this is what is called as the Miller's Law. He was a psychologist who first investigated it. In simple words, for better success, it would be a very wise decision to occupy those 7 spots in brain with useful information with a target in focus. Let me explain it in a simple way. When you talk with someone on cell phone, you focus on the talk. You focus on the subject on which you are discussing. You don't think about how circuit of cell phone works, what is electromagnetism, how does cellular tower work, how do they talk to satellite. No, we don't have to do that. We focus on our talk, and that exactly is the abstraction, hiding unnecessary complex details with reference to the subject in focus. So abstraction is the key to computing. The layers of a computing system gives you the idea of abstraction. Like an onion, each layer keeps on hiding the layer underneath. History. History is his story. Yes, it's a story. So let's enjoy the story of computing system. Feel like that this thing as a play where characters will come and go with their role in specific events, and finally we shall reach where we are today. And then a sneak peek into the exciting future to come. We shall see history of computing hardware and software separately because both have their own impact on development of computing systems. But remember that both hardware and software were progressing simultaneously. Talking about computing hardware first. This is Stonehenge, a stone structure that rises majestically out of the Salisbury Plain in England. It was built way back in about 2180 BC. Its purpose is still a mystery. There are some theories that the rising sun appears behind one of the main stones, giving the illusion that the sun is balancing on the stone. So one of the theories is that it was a temple. Another theory suggests that it was an astronomical calendar for position of sun and moon, and thus it was predicting eclipse. Quite like our Jantar Mantar in India, abacus. It appeared in 16th century, and it was developed as a device to perform some basic arithmetic function. Blaise Pascal. a French mathematician in 17th century who developed a mechanical device which was gear based, and it was capable of whole number addition and subtraction. Gottfried Wilhelm Leibniz. He was a German mathematician, and he later developed the first mechanical device designed to do addition, subtraction, multiplication and division, but it was complex. It was Joseph Jacquard in 18th century who developed a system. It was called Jacquard's loom. It was consisting of series of cards with holes punched in them to specify thread color and handling the design to be woven into the cloth. Well, it was not a computing device, but Jacquard's loom was the first to make use of what later became an important form of input, the punch card. Now in 19th century, Charles Babbage, a British mathematician, he designed analytical engine. His design was forced to include a memory so that intermediate values need not to be re-entered. His vision included many of the important components of today's computers, and his design was overly complex to build at that time, so unfortunately it was never implemented. But he gave a very important concept. Ada Augusta, Countess of Lovelace and the daughter of Lord Byron. She was a romantic figure in the history of computing. She was a skilled mathematician, and she became interested in Babbage's work on the analytical engine, and she in fact corrected some of his errors. Today, she is considered as the first programmer, and she gave the concept of loop, a series of repeat instructions. The programming language Ada used largely by US DoD for many years is named after her. In later part of the 19th century and beginning of 20th century, there were some rapid advances. William Burroughs produced and sold a mechanical adding machine. Dr. Hermann Hollerith developed first electromechanical tabulator, and it was reading information from a punched card. And also he formed a company known today as IBM. Year 1936. Alan Turing, a British mathematician, invented an abstract mathematical model called Turing machine. He died at the age of 41, disputed suicide by cyanide poisoning. There came a movie, Imitation Games, in 2014. It was a British historical drama film. Title of the film quotes the name of the game Alan Turing proposed for answering the question, "Can machines think?" It stars Benedict Cumberbatch as British crypto analyst Alan Turing, who decrypted German intelligence messages for British government during World War II. But still today, the most prestigious award given in computer science is the Turing Award, named after him. George Stibitz, 1937, he used relays to construct a 1-bit binary adder to add binary digits. 1938. Conrad Zuse, he built the first mechanical binary programmable computer. In fact, he is called as the inventor of the modern computer. 1939. Outbreak of World War II. Several general-purpose computers were under design and construction. It was the year 1943 when Thomas Flowers built the Colossus. It's considered as first all-programmable electronic digital computer. After the end of World War II in 1945, there came ENIAC, Electronic Numerical Integrator and Computer. It was unveiled in 1946 by John von Neumann. 1951. UNIVAC-1, Universal Automatic Computer. It was the first commercial computer, and it was given to the US Bureau of the Census, and it said that it used to predict the outcome of our presidential election. After 1951, the game becomes one of the ever-expanding use of computers to solve problems in all areas. From that point, the research was focused not only on building faster, bigger devices, but also on developing tools to increase the productivity. We talked about concepts and the history of computers. Let's talk about hardware generations. First generation, 1951 to 1959. Commercial computers in the first generation were built using vacuum tubes. They were not effective, requiring high maintenance, less reliability, and were getting heated enormously. Magnetic drum was used to store data. Input was in the form of punch cards. Output was in the form of punch cards or line printer. Later on, magnetic tape drives arrived. Well, they were much faster. Storage device which is outside the box of computer is called auxiliary storage device. And combination of input devices, output devices and auxiliary devices is collectively called peripheral devices. Second generation, 1959 to 1965. Electronic components, transistors arrived. These transistors were smaller, faster, durable and much cheaper. Bardeen, Brattain and Shockley were awarded the Nobel Prize for this. First time the concept of motionless magnetic core was given, and this resulted in faster memory access. Magnetic disks were used for storage. Third generation, 1965 to 1971. Arrival of integrated circuits. Solid pieces of silicon that contain the transistors, resistors, capacitors and connections. Integrated circuits were much smaller, cheaper, faster and much more reliable. Gordon Moore, one of the co-founder of Intel, noted that from the time of the invention of integrated circuit, the number of circuits that could be placed on a single IC was doubling each year. And this observation became known as Moore's Law. Auxiliary storage devices which still needed because transistor motion memory was volatile. This means information would be lost when the power is turned off. Keyboard arrived, monitor arrived. Keyboard gave the user instant input to the computer, and monitors display immediate result. Fourth generation, 1971 to 1980. VLSI, very large scale integrations. Personal computers arrived. Games like Pac-Man, Mario Brothers, all-time great. Atari, Commodore, they were considered as big players in gaming. Giant companies like IBM, Remington, DEC, HP stepped in. Came Microsoft. Watch this photo. You recognize anyone? That's the Microsoft staff in Albuquerque. December 7th, 1978. So you can see Steve Wood, Bob Wallace, Bob Greenberg. There is Bill Gates, Marla Wood, Paul Allen. Gates described this photo in 2009 as that famous picture that provides indisputable proof that your average computer geek from the late 90s was not exactly on the cutting edge of fashion. The best known success story of the personal computer revolution is that of Apple. Steve Wozniak and Steve Jobs created a personal computer kit and marketed it out of the garage. That was the beginning of Apple Computer, a multi-billion-dollar company today. Moore's law was modified. Now it is telling computers will double in power at the same price every 18 months. Concept of workstations and servers emerged. Fifth generation, 1981 onwards, ULSI, ultra large scale integrations. In fact, after 1980s, the progress has been so rapid that the concept of generation of computers has faded away. We are now in the world of intelligent computers, neural networks, artificial intelligence, where computers think and take actions by themselves. Networks are evolving at a tremendous pace. So at this point, let's have a bird's view of various types of networks and communications. Network is as discussed when devices talk with each other to share information and resources. This communication can be of four types. 1. Unicast, that is point-to-point communication, one-to-one. Second is broadcast. It is simple, one to all. Third is multicast, one to a specific group. And fourth is anycast. It's one to the nearest. Now it's available in IPv6, IP addressing scheme. So we shall be talking in detail about anycast in our future lectures when we'll be talking about IPv6. Networking is divided into several types as per its size. So first is PAN, Personal Area Network. Now this is within 1 meter. Say for example Bluetooth connectivity, RFID, smart cards, they are the examples of it. No doubt with the newer versions of Bluetooth, the range has increased. By the way, ever curious to know from where the word Bluetooth came? Well, he was Harald Bluetooth. He was the king of Denmark and Norway. Now King Harald Bluetooth was well known for two things: uniting Denmark and Norway, and his dead tooth, which was dark blue, that earned him the nickname Bluetooth. Now, Bluetooth is a wireless technology named after Harald Bluetooth, based on an analogy that Bluetooth technology would reunite devices the way Harald Bluetooth united the tribes of Denmark into a single kingdom. Stated in Ericsson website also. Dr. Jaap Hartson invented Bluetooth while working at Ericsson in the 1990s. How about the symbol of Bluetooth? It is the initials of Harald Bluetooth in runic alphabet, H and B. The next is LAN, Local Area Network. It's a privately owned network in home, office, campus. It could be wired or wireless. So when wired, it is using Ethernet technology, and when wireless, it is 802.11. More about it as we progress further in our series. The next is MAN, Metropolitan Area Network. It covers a city. Cable television network is one of the example. WAN, Wide Area Network. It spreads across large geographical area. It could be city to city or country to country. The major difference between LAN and WAN: LAN is local, WAN is global. LAN uses private IP address, WAN uses public IP address, and we shall be talking about public and private IP addresses in our next lecture. Complexity of WAN is more than LAN. Recurring cost is associated with WAN in the form of subscriptions, which is to be given to internet service providers. LAN is your own, it's within your own premises, so you don't have to pay anything to run it. LAN uses IGP, Interior Gateway Protocol, like RIP, OSPF, EIGRP, while WAN uses EGP, Exterior Gateway Protocol, like BGP, Border Gateway Protocol. LAN is relatively easy to understand, while WAN requires some sort of imagination, especially the complex topics like say BGP, MPLS, VPN, etc. But there is one another genuinely nice concept called cloud computing. Entire infrastructure is located at one place, and via internet you are given the specific services. So say for example, instead of installing servers, keeping administrators and handling and managing your bandwidth for email solutions and then the security of it, you use Microsoft Exchange 365. This is what is called as software as a service. You are given a dashboard from which you can handle your entire email solutions for your company. However, the hardware is running at the Microsoft stations managed by Microsoft engineers. You just enjoy the service without going into the details of managing the hardware, securing it, upgrading it. This is one another example of abstraction. Amazon Web Services can also be considered as an example of abstraction. You can build your own computers virtually, use them. Moving on to software generations. First generation 1951 to 59. The first program was written using machine language. The instructions built into electrical circuitry of a machine. It was using binary 1 and 0. Deep knowledge of mathematics was needed. It was time consuming, prone to errors. But some programmers developed tools to help the programming process. So these tools helping the programming process were called assembly language. They were sort of software translators. They were like buffer between programmer and hardware. So there were two types of programmers. Programmers making tools, programmers using tools. Second generation software 1959 to 1965. High-level languages appeared. They allowed the programmers to write instructions using English-like statements. COBOL, Common Business-Oriented Language, Fortran, Formula Translation are some of the examples. The introduction of high-level language allowed running the same program on more than one computer. A program written in a high-level language has to be translated into machine instructions to be executed. Such a translation is called a compiler. So at the end of second generation, the role of the system programmers was becoming more well-defined. System programmers wrote tools like assemblers and compilers, and these tools were used to write application programs. So here is the complete hierarchy inside out. Machine language, assembly language, high-level language, system software, and application package. Third generation software 1965 to 1971. Now during the third generation of commercial computers, it became apparent that the humans were slowing down the computing system. Solution was to put the computer resources under the control of the computer. That is, to write a program that would determine which programs were run and when. And this kind of program was the first operating system. So there were loaders. They would load program into memory, and there were linkers. They linked pieces of large programs together. All of them collectively called system software. Basic, beginner's all-purpose symbolic instruction code was introduced. Fourth generation 1979 to 1989. Introduction of better programming technique called structured programming, a logical disciplined approach to programming. Pascal and Modula 2 are the examples. Basic, which was introduced in third generation, was refined and upgraded. C++, a structured language, came into use. Better OS in the form of Unix, PC-DOS, MS-DOS came into existence. Application programs like Lotus 123 for spreadsheet, WordPerfect was for word processing, DBase 4 that was for database management. Apple came up with the concept of mouse, a very special device. Ever wondered why was it called mouse? Well, looks like mouse. It has got a tail. Well, Apple said it's a device which will enhance user's system experience. So mouse is Macintosh operated user system enhancement. That's why mouse was called mouse. Fifth generation 1990 to present. Microsoft game with Windows operating system, Office suite, object-oriented programming in the form of Java. It's based on hierarchy of data objects. HTML hypertext markup language was created for World Wide Web. Browsers like Chrome, Safari, Opera, they came up. Current work is on embedded system. Their software is integrated into the hardware. And this is awesome for automation in multiple areas ranging from smart home to medical systems to defense. This was the first step towards computer networks. Now this takes us with understanding that computers are integrated into our life at every level. Some big ideas in computing: creativity in the form of audio, video, infographics, animation, whether we use it for games, entertainment, movies, medical, defense, and so on. Abstraction, that's the idea for the robotics and animation. Data and information for knowledge. Programming for solution to the problems. Internet for communication and sharing resources. Combined effect, it enables innovation. The global impact is phenomenal, but effect can be positive as well as negative. And the same way, there are positive and negative effects of computers on our mind also. What do you think they are? Express your views in the comment section. Coming up with another session very soon. If you are not subscribed, kindly subscribe and press the bell button so that you are informed immediately as soon as the new session is released. Wish you all the best. Thank you so much.